Hi everyone. In this video, we're going to learn how to evaluate functions. Let us have example 1. Given the function f of s equals 2s plus 3, let us evaluate a. F of 2. Letter b. F of 2 plus h. Letter c. Fraction whose numerator is the difference of f of 2 plus h minus f of 2 all over h. Letter D. Another fraction whose numerator is the difference of f of s minus f of a all over s minus a. Let's begin with letter A. Let us evaluate f of 2. To evaluate f of 2, we are going to copy again the given function. We will write here, but instead of s, we will substitute the value that is written here, which is number 2. So we have now 2s now becomes 2 times 2 plus 3. And then from here, let us simplify further. 2 multiplied to 2 will be 4 plus 3. And 4 plus 3 equals 7. Therefore, the f of 2 equals 7. So we will write the answer here. Then we will proceed with letter B. The f of 2 plus h. The same idea. I am going to copy the same function. I will write here, but for the s, I am going to substitute the value 2 plus h. So we have now 2 times the quantity 2 plus h. Then plus 3. Simplifying this, we have now 2 times 2 will be 4, and 2 times h is 2h, then plus 3. We will now add together 4 and 3. It becomes 7. So our final answer here is 2h plus 7. Then we simply copy this answer in here. Then let's go to letter C. Let us simplify the fraction. The numerator is f of 2 plus h minus f of 2 all over h. I hope you notice that the first function here is our function b. And the second function f of 2 is our first function a. And all over the h. So just to show, we will do like this. For the f of 2 plus h, we will consider again that same function. We will copy here, but instead of the s, I will put the 2 plus h. So we have here 2 times the quantity 2 plus h, then plus 3. This is for the f of 2 plus h. Then minus the f of 2. The same idea. I will copy this function in here, and then for every s that I see, I will change by the number 2. So we have here 2 times 2 plus 3. Then all over the h. Actually, we solved this already, and this is the answer, letter B. And the second function, we have the answer already in problem A. We can simply substitute the values of A and b respectively. So we have now the group 2h plus 7 minus the 7 all over h. And to simplify further, if I remove the grouping symbol, the positive 7 and the negative 7 here will cancel each other. It becomes 0. So on the next line, we can put here 2h all over h. And the h in the numerator and in the denominator can be cancelled out. So we have now our final answer to be 2. And we can write this answer opposite letter C here. Then let's go to problem D. The fraction is f of s minus f of a all over s minus a. The f of s is the original problem, so we can copy it here, the 2s plus 3. Then minus the f of a is this function, but instead of the s, I will copy the a. So you see here 2a plus 3. Then all over, same denominator, s minus a. Let us simplify further. Let us remove the grouping symbols respectively. In the first group, we can directly remove the grouping symbol. But for the second group, if we remove the grouping symbol, we need to change the sign of all the terms of the second group. So we have now 2s plus 3 minus 2a minus 3 all over s minus a. Did you notice this is positive 3 and this is negative 3? When we combine together, it becomes 0. So we have now 2s minus 2a all over s minus a. In the numerator, there is a common factor which is 2, and we can factor it out. So the number 2 is factored out, then multiplied by the s minus a. This s minus a has a counterpart in the denominator, which is s minus a also. It means we can cancel the s minus a and the s minus a in the denominator respectively. So the final answer is 2. And we copy this answer opposite this letter D. So we finally completed our answers for example 1. These are our final answers. Let us have example 2. Given the function f of y equals 2y squared plus 5y plus 1. Evaluate this fraction whose numerator is f of y plus h minus the function f of y all over h. Let's begin with the step 1. Let us simplify this function f of y plus h. It means to say, I'm going to copy the same function here, but every time there is y, I will change that value by y plus h. So you see here, we have 2 times the quantity y plus h, and it is squared, plus 5 times the quantity y plus h, plus 1. Then let us simplify this square of binomial. I hope you still remember the special product when we have the square of a plus b. The answer is a squared plus 2ab plus b squared. We will apply this idea in the square of y plus h. So we have here 2 times the quantity y squared plus 2hy plus h squared. Then plus, we'll just copy all the remaining terms in here. Then on the next line, we will multiply the number 2 to each term of the trinomial. Also, this number 5 will be multiplied to the binomial here. So we have 2y squared plus 4hy plus 2h squared plus 5y plus 5h plus 1. So we are done with our step 1. This is the value for this f of y plus h. Let us go to step 2, and that is evaluate the given problem here. So this is f of y plus h minus f of y all over h. Let us substitute the values. The first function was evaluated in step 1, and then minus the f of y is the given function here. So we copy it here, then all over the h. We will simplify further. Let us remove the grouping symbols respectively. In the first group, which is a big group, we can directly remove the grouping symbol. While in the second group, it is preceded by a negative sign, we must change all the signs of all the terms of the second group. So we have now 2y squared plus 4hy plus 2h squared plus 5y plus 5h plus 1. Then this negative 2y squared minus 5y minus 1. And then let us see some terms that we can combine. I see here 2y squared, and there is negative 2y squared here. Also this positive 5y, and there is negative 5y here that can cancel each other. There is positive 1 while there is a negative 1 on the last part here. So they can cancel each other respectively. So on the next line, we will simply collect the remaining terms. And the terms are the 4hy plus the 2h squared plus the 5h all over h. In the numerator, there is a common factor which is h that we can factor out. So h is factored out, multiplied by the trinomial 4y plus 2h plus 5. And we can see that there is an h in the numerator with a counterpart h in the denominator, and we can cancel those h. So we have now the final answer, 4y plus 2h plus 5. This is our final answer. I hope you learned something from this video. See you again next time.